I have kind of always been interested in math, so I just decided to stay in it as long as I could, and then I'm still here. So in my research, I'm working in what I like to call geometric arithmetic statistics. So I like to study how often certain things happen in geometry, meaning like how often do certain curves have rational points or degree d points, where a degree d point is a point that's defined over a degree d extension of q. And so something that's interesting is, when do you have a rational point, when not, but which degrees are possible for you to find points of those degrees. And then that's called the index of a curve, the GCD of all possible degrees that you can have a point defined over that degree. And so I'm interested in studying that. We know the index for some families and some examples, but it's still, there's no algorithm to determine the index of a curve just from its equation. So right now I'm working with 2 undergraduates on a project related to something I did in grad school. It's related to something called moonshine, so which is a relationship between finite simple groups and modular forms, or more generally automorphic forms. And so they're working on finding some arithmetic applications of a module for subgroups of M24. I like the people in the math department here. I really like our atrium. We have these nice chalkboards and places to sit, and it's really nice to see students collaborating there, especially when they're working on things I've assigned them. And then the other thing is the math gym, which is going to be amazing. It's a room upstairs in 505, and it's floor-to-ceiling whiteboard and modern furniture, and you can just go there with students or collaborators and, work on whatever you want. So I was a postdoc at Berkeley last year, and there I taught number theory, elementary number theory, and abstract algebra. And the elementary number theory was referred to in my formal course evaluations as the dessert of math classes at Berkeley. So I'd like to teach that here, but right now I'm teaching abstract algebra, which is really fun, and last semester I taught linear algebra. Yeah, I would say to a grad student who's trying to get started in research, I would say try to go to as many seminars as possible. Go to Colloquium. Sorry, that was a shameless plug for Colloquium. I really want Colloquium to be, everybody goes there, so we've got some good speakers coming, and the talk should be accessible to everybody, so go to Colloquium, go to seminars, travel to conferences, use the resources that the department and the university has for you to travel, and then try to go to dinner with the speakers if you're invited. So. Okay, so we have this conference that rotates between UNT Oklahoma State and the University of Oklahoma called Texas Oklahoma Representations in Automorphic Forms, and it's here every 3 years or so. It's a really great opportunity. You can just register, you'll get a name tag, get to go to the talks, meet speakers and a bunch of people who traveled in those areas. So I give these handouts on holidays to my students. This is the one for Valentine's Day for abstract algebra. There's 2 jokes. So the first one is, A asked A inverse, will you be my Valentine? And A inverse said to A, but I'm already in the subgroup generated by you, so that would be gross. And then A said, okay, but let it go, and waited, but next year he asked A inverse again, and then A inverse said the same thing because A inverse was still in the subgroup generated by A. And this happened again next year, and the next year, and the next year. I guess it was cyclic. The other joke is, why did Z mod 2Z break up with Z mod 4Z? It was because Z mod 4Z wasn't faithful in their relationship. Because the map from phi from Z mod 4Z to Z mod 2Z is not injective. Okay, the unpopular costume. So there's some matrices here, and then there's 24 says, do you like my costume? And then this matrix here says no, and then this his twin brother, I guess, says I just can't determine it. Because the determinant of that matrix is 24.